And let's see another problem based on heap data structure. So try to understand the problem and we'll utilize this data structure to solve the problem. So the problem is a hand of straits. It's a medium level problem. First try to understand what this says. It says LS had some number of cards and she wants to rearrange the cards into groups so that each group is of group size and consists of group size consecutive cards. Okay, so there are two parameters. One is the array hand and another is the group size. So let's analyze this based on this input and output, what it's saying. So if you see this array, so we can start from like 1 to 3, and then it's a group size is 3, so we can take the item like 1 to 3. That's we can take 3 items 1 to 3, so that's good. And once it's done, we can again see there is another item, like we can find the 2, so from we can also see 2 3 4, and then it's like 6 7 8. So we can see this the consecutive item starting from some beginning number, and the size is 3. So that means in this case it will return true. We can also check this length of this should be divisible by 3. So it's like 3 and 6 and 9. So if it is divisible by this group size, that's also return true, but if not, then return false. So let's see another example here. In this case, a group size 4, so you can start from some number like 1, and we can see the consecutive number 1 2 3 4. So that's good. Again, once this is done, we can start from the 5, and there is no consecutive numbers, so that's return false. Or we can also think if it is in the if it can be divisible by this group size. So this group size is 5 and it cannot be divisible, so in that case also it's a return false. So that's the requirement, and how to solve this, let's try to understand. So let me copy this first and move to another screen. So what I'm going to do, in the first I will store this data in a map. So in a map, if I store how this looks like. So in a map, let's say I store 1, so 1 and then 1 count is 1, so that's and then for 2, so 2 count is 2, and again for 3 you can see the 3 count is 3 occurs 2 times, so it's 2, and 4 occurs 1 time, so 1, and 5, there is a 5 here, so 1 2 3, and then should be 1 2 3. Okay, and then again it can start from 2 3 4, so 2 3 4, and then 6 7 8, so it's a 6 1 and 7 1, then 8 1. So first I will store this this data in a map, so in that way this will be key, and we can also put the count as a value. So that's the first step. And then second step, what we can do, we can add this key in a heap data structure, and there is a like two property of heap data structure. We can say like it can say like min heap or max heap. So here we are going to use the min heaps. And what is the min heap? So if you try to understand in a main heap, if you put the item inside the main heap, then the smallest item is always on the top. So whenever we remove the item, the smallest item will come from the heap. So that will be arranged in that order, in such a way that the minimum item is on the top, and in the max heap, the max item is at the top. So here we are going to use the min heaps, and how this is going to work, like first what we do, we add all the keys in a main heap. So in a main heap, like let's say inside a heap, we have all the key here, like so 1 2 3 4 6 7 8 6 7 and 8. So that main heap contains this. So if you remove the items from the heap, you will get the smallest item from the heap. Okay, so what will you do first? We'll remove one item, 1, from the heap, and then we can check this 1 exists in a map or not. So if it doesn't exist, then return false. But we know that this 1 exists in a map. So there is a 1 entry for this. So that exists, good. And then once we find this in a map, what we do, we'll start from this item, and we can iterate to this group size. So if I can add this 3 to 1, so group size will be 4. So in that way, I can get 1 2 and 3. If I iterate 1 to 4, then I will get the item 1 2 3, and I will keep checking if the 1 2 3 that exists in a map or not. So first I will check 1 exists in a map, and its a entry is this account is 1, then I can delete this item. And then again I'll get the 2. I'll see the 2 exists, but the entry is more than 1. So in that case, I will decrease this value 1. And then again I will check 3, and 3, this entry is true, so I will decrease this 1 from the map. So that's this one iteration is done. So next time, again, this is the inner loop. So again, once we delete the item 1 from the map, we'll delete from here also, delete this, delete it, and from heap also it will be deleted. Okay, so again that will be in the loop itself, outer loop, and we'll get other item from the heap, and in this time 2 is the smallest item, so we'll get the 2, and again we'll check 2 is in map or not. Yes, 2 is in map. So now we'll iterate from 2 to group size. So group size is 3, so I can add 3 to here, so that's a 5. So I will iterate from 2 to the item less than 5. So then I will check 1 by 1 item in a map. So I will find the 2, and the entry is 1, so I will also delete this item. So deleted. 3, so 3, it's a 1 entry, so again I will delete this item 2 3, and similarly I will delete from here also, deleted, and it's also deleted, it's gone. And then 2 3 4 entry, that's also entry is 1, so this also I will delete. So I will say okay, deleted this item, and 4 also I will delete from here, deleted. Okay, so that's inner loop is done. So the remaining items are 6 7 8 in a heap. So I will get another item from heap, that is 6, and then I will check I'll check that 6 in map or not. Yes, it exists, and then I will iterate the loop from 6 to the group size. So group size is 3, so that's it goes 9, so that means the consecutive items starts from 6 to less than 9, so 6 7 8. I will check that okay 6 7 8 are in map, and the entry is one time, so I will delete this also. I will delete this item and delete this item, and then in the same way I can delete from the heap. Delete and delete. So heap is empty in this time, so in this case I can return true. But if you take another example, so in another example there will be some, it will be returned false in somewhere. But if you utilize this two technique, map and min heap, we at the end, the heap size will be empty and we can return true. So that's what we are going to do to solve the problem. Let's see the code. Okay, so I'll come back here, and in the golang we can import the container heap, and we have to implement few functions. Like there are 6 functions we have to implement here to use the heap in a golang. So let's do that. So I'll define type init heap. It's the array of int, then function, so length function. It's going to return the length, return length of h, and another one, it's a less function. It's going to return the boolean, and here we can say hi less than hj. So this is, if I say hi it's a less than hj, it's a min heap, and if I say hi greater than hj, that will turn to max heap. So based on this we can create the min heap or max heap in a different problem. Let's implement another function, h init heap. It's a swap ij int, it's a hi hj equal to hj hi. So 3 and then 2 more functions. Yeah, I said 6, yeah, but just 5 functions. 3 and 2 more. One is push and pop, so let's use that. Let's use h init heap, and here in this 2 we do not need this pointer in this 3, but in this 2 we need pointer. So init heap is a push, and so you can do star h equal to append star h item, and you can give the type of this item, so it's an int. So push is done. The last function is pop. Pop is the any. I can store this h value here, the new variable a. L is going to be the length of a, and I can get the last item. So last item is a, and L minus 1 I can return this item. Then before returning, also I can assign one less item to this h. So h go to a -1. Okay, so this main heap is done here. So we can utilize this main heap. So we'll come to this list. First we can check whether it's a divisible by group size or not. So if len hand divide by group size not equal to 0, then return false. So you can check this condition. Next thing is we can store this item and the count in a map. So let's create a map. So make map int. Then you can have a loop here for, so I do not care index, so that's underscore, and then it's a v range, it's a hand. We'll get the item one by one. You can store this in a map. So map so v, that's the item, and the entry is 1. So first time I say 1, and then I can check its existence. So it's a mp count. Okay, and you can say if item already exists, then increment the count. So in this case, so mp equal to count plus 1, and this will be in else version. Okay, so our map is ready. So the next step is, you can store all the keys of this map to heap. So let's initialize the heap. So for that we can do h, so init heap, and then heap dot init h. So we can initialize this h heap, and now we can store this map keys to heap. So let's iterate the map. It's the key value. So we are going to store just key, so I do not care the value, so that's underscore, and then range, it's a map. So let's put this key, all the keys in a heap. So heap dot push k. Okay, so we put all the keys in a heap. Now let's have one outer loop and inner loop, and the main logic goes here. So it's outer loop for, I can check h dot len greater than 0, and come here, and we'll get one by one item from the heap. So let's get the item. So it's element h dot, so heap dot pop. So when you push the item, like we say heap push, and then we have to mention the heap variable name, and then key, and then pop, heap pop, and then h that. So we'll get the item. We'll convert this item to int. Okay, so we have the item now, and then we get the top item, that is the smallest item from the main heap, and we collected this in a variable and again put it back. So heap dot this h that item. Okay, next thing is we can check, like in a loop we can check this item to, the group size item. All the items between this exist in a map or not, and the count is 1, delete. If the count is greater than 1, then decrement the count. So let's do that. So I can say for I equal to, it's the item, and then item less than item less, not item but I less than item plus, it's a group size, and then I plus plus. Okay, so we'll get the item one by one and check that whether it exists in a map or not. So and check map I can say the count and okay. If not okay, that means not exist, then return false. Otherwise, if it exists, then we can check the count. If count greater than 1, then we can decrement the item. So in this case, what I can do, map I equal to this count minus 1, and if the count is 1, then delete the item from map and also from the heap. So it's delete in and item, and also delete the item from the heap. So it's a pop the item. So heap dot pop h, that's all, and then at the end we can return true. Yeah, so in this way, we can check this. Let's run this first. $65 return 66. Let's run this. Okay, now let's try to submit. Okay, that's a good, it's accepted. So that's the solution. Let's see the solution in a Java also. So it's the same approach I have already done in a Java. I'll just go through the code. Okay, so if it's the Java, so in a Java, the way we create the heap with the help of priority queue. So the default is main heap. So we create the main heap here, and we create the map, and we check, it's a divisible by group size or not. We can return the false, and we can iterate through this array, and we can add all the entry to the map. If it is the first time, then the count is 1. If it's already there, we can increase the count. So we added the item in a map, and we get all the keys from the map and put that in a heap. So here is a priority queue, so you can say I can put that in a heap here, and then outer loop, I'm getting the item one by one out of the heap. So I'll get the item, I store this in a item, and then add back again in the heap, and then I'll start from the item and get all the consecutive items till group size. So it's a less than group size. So I'll get one by one item, and I'll check in the map. If it doesn't exist, then return false. If it exists, then I will check the size. If the size is, if the count is greater than 1, then I'll update the map. I will decrease the count of that value. If the count is 1, then I can remove from map and also from heap, and at the end I can return true. So that's all. So that's all for today. Thank you.